Alright guys, today's lesson we're going to solve trigonometry equations involving compound angles. Now before we start, I'd like to do some revision for everyone about a compound angle formula. Now the first one is the basic compound angle formula, and we have 6 of them. Alright, 6 basic compound angle formula there. And the first one is sine A plus B. If you have sine A plus B, then the answer will be sine A cos B plus cos A sine B. And of course, if you change that to sine A minus B, then you just have to change the sign in between, which is minus there. Alright, so cos 1 is different. Cos A plus B is equal to cosine A cosine B minus sine A sine B. And then cos A minus B, so if here's minus, then the formula here is plus. If inside the brackets here is plus, then the formula there will be a minus. Alright, so that's something that you should know. Alright, again for the tangent, here's the tangent formula there. Pretty easy, you have learned this before from the year 11 content. The next one you need to know is the double angle formula. Alright, again, nothing special, but you do need to remember that is the double angle formula for cosine, and then from here you can generate into 2 other formulas here in terms of cosine and sine only. And obviously this comes from, let me just write this one down. Alright, how do we convert it into those formulas there? Well, you know that sine squared theta plus cos squared theta is actually equals to 1. Alright, so therefore you can actually do some rearrangement using algebra to prove to these 2 formulas there. Alright, the next one that you need to know is the T formula. I know some students that don't like T formula substitution or T formula calculations, but sometimes T formula is really useful because you can change the trigonometry equation into kind of like an algebra equations, right, without a trick there. Very useful, and you do need to memorize the formula there. But something that you need to be careful about is, usually for the T formula, I like T to be tangent half theta, okay? But sometimes with questions, you can let T to be tangent theta. So as you can see here, instead of half theta here, it's actually theta. So if that's equal to theta, then that means you can have tangent sine 2 theta equal to 2t over t plus 1 plus t squared, and then cos 2 theta equals to 1 minus t squared over 1 plus t squared. So as you can see here, the formula here stays the same. The only difference is you just need to make sure that you let t to equal to tangent theta. Alright, okay, so the next one, alright, is the sum to product to sum, alright. Very useful. You're doing those formulas coming from the compound angle formulas, which I'm not going to mention right now. Okay, we're going to look at a couple of questions, and we're going to see how are we going to incorporate those formulas to solve trigonometry equations. Now remember, trig equations are not easy to solve, alright, and sometimes you do need to apply a couple of formulas before we can solve it. So here's the first question. Solve for theta between 0 and 360 degrees. So the first question is, let me pick a good one. The first question is 2 sine 2 theta plus cosine theta equals to 0. All right, with this question here, how do we solve this question? All right, how do we solve it? In order for you to solve this question here, you need to understand that 2 theta need to be changed into 1 theta. All right, with 2 theta here, you can't really solve the question. Alright, so you're going to use double angle formula. So that's the first reaction. When you see 2 theta, sine 2 theta, alright, firstly, think about it, double angle formula. So that means if we change that into double angle formula, that becomes 2 sine theta cosine theta plus cosine theta equals to 0. So that gives us 4 sine theta cosine theta plus cosine theta equals to 0. Now once you get to this point, then the rest of the step will be just factorizing. So you take the 4 outside, so that becomes 4 cosine theta bracket sine theta plus 1 equals to 0. Okay, sine theta plus 1 equals to 0. And then from here, you should be able to solve the question quite easily. Alright, once you get to this point. Because once you get to this point, all you have to do now is sort of like using the normal algebra method to solve the question. So, all right, I hope you guys will know how to do those questions here now. All right, so once you get to this point, then we just let 4 cosine theta equals to 0, and then sine theta plus 1 equals to 0. All right, and then that gives you cosine theta equals to 0, sine theta equals to minus 1. And then after that, you can use your calculator to work out the answer. But remember, the domain is between 0 and 360 degrees. Okay, so this is very important that you guys need to remember this. All right, okay, so for the first one, cos theta equals to 0, theta is pi on 2, okay? Oh, wait, we're using degree this time, so it's 90 degrees. All right, the second angle you get is all station to central, which is using 360 degrees minus 90 degrees for cosine. So that gives you 270 degrees. Now, for the sine on the other side, sine theta equals minus 1. Theta is minus 90 degrees. Minus 90 degrees. All right, and then once you get, minus 90 degrees, then the second angle, again, according to angle, all station to central, it is 180 minus the angle you get from the previous one, which is negative 90 degrees. So that gives you negative 90 degrees and 270 degrees, which is the same as the previous one. All right, and of course the next one is 360 plus negative 90 degrees, which is again 270. All right, so as you can see here, the answer for this question will be just 90 and 270 degrees for this question there. All right, so if you just run to right, theta is 90 and 270, that becomes the answer of this question. Pretty easy. All you need to do is the double angle formula for sine, and then you solve the question. All right, so that's an easy one. Okay, all right, so let's just do another one. All right, let's try this question here. So the second question I'd like to try, that's the first one, is this one here. How do we solve cosine 2x plus 3 cosine x plus 2 equals to 0? Okay, how do we solve this question here? Again, the domain is still between 0 and 360. We're going to do something that's, using the radian later. All right, so how do we solve this one? You have 2x, you have x. Now remember I told you before, you can't really solve the question if you have one equals to 2x, the other one equals to x. So what you need to do is to try to convert this one into x. Now with cosine 2x, the double angle formula is a bit tricky. You've got 3 of them. All right, and you need to remember which one to use. Here is cosine x, right? So if you look at that, that's cosine x. What you want to use is the one with the cosine x. Okay, and I hope you still remember that becomes 2 cosine squared theta minus 1. All right, actually using x in this case. That is the formula. So go back to the double angle formula for cosine is 2 cosine squared theta minus 1 for that. Okay, so you need to pick the right one to use when you solve the question. All right, so once we know which one to use, then we can actually start now solving the questions. So we can change that into 2 cos squared theta minus 1 plus 3 cos theta, or x, sorry, that should be x, plus 2 equals to 0. So that gives you 2 cosine square x plus 3 cosine x plus 1 equals to 0. All right, once you get to this point, now that looks like a quadratic. So the next step is you can let a equals to cosine x. So replace cosine x by a, then you get 2a squared plus 3a plus 1 equals to 0. All right, so you can solve this quadratic equation, and once you can solve this quadratic equation, then you should be able to solve the trigonometry equation. So that becomes 2a plus 1, which is equal to 0. So a is minus 1, a is minus half. All right, so once you get a equals minus 1 and a equals minus half, the next step is, remember you still haven't finished solving the question. What you need to do is to work out what is the value of x, right? So the next step here, which I'm just going to do on this side, is we're going to write down x, cosine x is equal to -1, and then cosine x is equal to minus half. All right, very important. Okay, so now you get to this point. Now the next step is let's solve it, all right? Let's solve the equation. So use your calculator, all right? X is equal to cos inverse minus 1. And the answer here is pi, which in terms of degree, that would be 180 degrees for the first one. For the second angle, is 360 minus 180, which in this case, it is still equals to 180. So I don't have to write, 2 times. So that's 180 degrees for the first one. For the next one, x is equal to cos inverse negative half. All right, so you need, again, use your calculator to work out what is negative half if you do cos inverse. And cos inverse negative half, what is that equals to? I don't have a calculator here. Cos negative half. Let me just use my iPhone and see if that works. I should bring a calculator next time. All right, it's 120 degrees, okay? Looks like my iPhone is pretty good, okay? So I'm just using my iPhone calculator to work out this answer here. That's 120 degrees anyway. All right, so that gives you 360 degrees minus 120 for the second angle. Then you get 120 and then 240 degrees. All right, so now that's all. All right, so the x is 120, 180, and 240 degrees in ascending order. And that is the answer for this question. Still pretty easy. We're still using the double angle formula to work out the answer. So I believe this question can be still easily done. Okay. All right. Let's move on to the next one. All right, so this time, let's say this is example 2 this time, all right? So example 2 will be slightly harder. All right, so this is example 2. First part of the question asks you to show that sine 3x is equal to 3 sine x minus 4 sine cubic x. All right, so that's the first step. And then in the question B asks, hence, so you're going to use the first part to solve the equation sine 3x plus sine 2x is equal to sine x. You're going to solve that equation using the first part for x between 0 and 2 pi. All right, now how do we solve this? The first step is we need to show, right? We're going to start from the left hand side. So we're going to show that left hand side sine 3x is equal to the right hand side. The right hand side, 3 sine x minus 4 sine cubic x. Now, something that you have to pay attention with is they're all equals to sine x. All right, so they're all sine, nothing in terms of cosine. So make sure that, remember, when you're doing the questions, you need to leave everything in terms of sine. All right, so how do we do it? Well, that's 3x, you need to break down into 2x and x. Very important, break down into 2x and x. And then you use the double angle formula, all right, to expand this. So you get sine 2x, cos 2x, all right, cos x, cos x, plus cosine 2x, and sine x. Okay, all right, once you finish up to here, then the next step here is start to think about how do I change everything into sine. Okay, that's something that's really important. I want to change everything to sine. How do I do that? Okay, so how do we do it? For the first one, sine 2x, we can use the double angle formula. So that gives you 2 sine x cosine x. And you do have another cosine x here, which means that cosine x will be a bracket to the power of 2. All right, plus. Now, with this one, you're going to use the double angle formula for cosine 2x, but this time, remember which one to pick. I want to change everything to sine x, all right, in terms of, sine ratio. So I want to change that into 1 minus 2 sine square x this time. After you're doing that, you're going to get 2 sine x, all right, cosine square x plus sine x minus 2 sine cubic x. That's pretty good. At least we've got a cubic. All right, keep going. Now, how do we change that? Well, using Pythagorean identities, you get 2 sine x bracket 1 minus sine square x. So as you can see, just one simple question that takes that many of the steps to do it. So now you can expand. And after you expand, you should be able to combine, okay, the like terms. So where's the like terms? Well, this negative 2 sine cubic x, that's another negative 2 sine cubic x. That's the same, all right, and then these two are equal to each other. They are the same like terms, so that becomes 3 sine x minus 4 sine cubic x. And that is equal to the right-hand side. All right, proved. For the first question, done. Now we need to solve the second part of the question. All right, so how do we solve the second question? They use the word hence. That means you have to solve the question using, the previous answer there. All right, so to solve that sine is 3x, I'm just going to copy the question down. To solve this question here, we need to use the previous answer that we got. Right? The previous answer tells you that sine 3x is equal to that. And then we just need to replace that into here. Okay, so let's do it. Okay, so that becomes 3 sine x minus 4 sine cubic x plus sine 2x is equal to sine x. All right. So we get up to here. All right. What do we do? Looks like we need to continue to do the question. Okay. All right. So let's combine these two like terms. That becomes 2 sine x minus 4 sine cubic x plus sine 2x equals to 0. All right. That looks interesting. Okay, so how do we solve this? So we've got 2 sine x, let's continue with that, minus 4 sine cubic x plus 2 sine x cos x equals to 0. Very interesting. Looks like I can't solve this question right now, but who knows, right? Let's continue. Maybe we can just take the 2 sine x outside, and we're going to get 1 minus 2 sine square x. That looks promising. And keep going. So that becomes 2 sine x, and here is cosine 2x equals to 0. All right, now when we get to this point, finally, I think I know how to solve this question now, all right? Because once we get to this point, then the next step here is you take the 2 sine x outside, you have cosine 2x plus cosine x equals to 0. So it's a really hard question here. Now, you're going to break that into two parts, 2 sine x equal to 0, and then cosine 2x plus cosine x equals to 0. Two parts. So that one is sine x equal to 0. You can solve that one easily. But however, on this side, what you need to do is further break down into the double angle formula for cosine, and that becomes a quadratic equation. Gosh. It's a bit crazy, okay, for this one here. And I'm just going to quickly do that. So that gives you cosine x plus 1. After you factorize it, you get 2 cosine x minus 1 equals to 0. Oh, wow. So now you get cosine x equals to minus 1, and then cosine x equals to half. So what does that mean is you're solving how many equations? You're solving, let me just pick a cool color here. You're solving 1, 2, and 3 trigonometry equations, all right? There's 3 trigonometry equations. Sine x equal to 0, cosine x equal to minus 1, and then cosine x equal to half. So it's a really hard question here. All right, so let's do that. All right, do I still remember them? No. So sine x equal to 0, that's the first one. Cosine x equals to minus 1.5. So cosine x equals to, is that minus 1.5? Yep, sorry. All right, so solving these three trig ratios now, trig equations now. All right, let's start. All right, x is equal to 0 for the first one. The next one is pi. All right, this is in terms of radian measure. Here, cosine x equal to half, that becomes pi, which is 60 degrees, pi on 3. And then you're going to use pi minus pi on 3. And you're going to get 2 pi on 3. All right? Oh, excuse me, sorry. All right, so the next one is x equals to pi. And then if you use 2 pi minus pi, it is still equals to pi. All right, now combine the answer together. You have 1, 2, 3, and 4. 4 answers. You got double pi, but that just consider as a pi. So now finally, your answer will be x equals to 0, pi on 3, 2 pi on 3, and pi. Okay, that's how you solve this question. All right, pretty hard. Because even you use the first one to do a substitution, like for example, even if you substitute all of this into here, you still need to know how to solve the rest of the question by using, what's that called here? By using factorization here. And once you factorize, this becomes the double angle formula going backwards. And I'm going to factorize all of these again. And then you have to solve 3 separate trigonometric equations to get the final answer. All right, I would like to do one more. How about just gonna pick a really hard question to do? If that, I'm not really sure if this is hard or not, but looks pretty hard. Okay, that's example 2. So let's just call this as example 3. All right, example 3. This is the question, and this time it's in terms of cosect and cotangent. Square root of 3 cosect square alpha equals to 4 cotangent alpha. Okay. All right, wow. We're going to find the answer between 0 degrees and 2 pi. Okay, so it's a radian measure. How do we solve this? Now, it's really hard to solve question if it's in terms of sect and cotangent. At least I am not confident of doing that, okay? So one way you can do it is you can change the cosect square into sine. All right, so it becomes 1 over sine, and you can change the cotangent alpha into, cos over sine. That's one way you can do it. But just with this question here, there is a formula you can use where you can make the question much easier to solve. And that formula is 1 plus cotangent square is equal to cosect square alpha. That formula. So then what does that mean is you can replace the cosect square alpha by 1 plus cotangent square alpha. And hopefully that makes your calculation a bit easier to do. All right, so let's do that. Because once you change into here, then you don't really need to change into tangent if you don't want to. All right, that just becomes, again, another quadratic equation problem. All right, so if I let's just say this time theta, probably not theta, let x equals to cotangent, not cosine, cotangent alpha. So you're going to get square root of 3x squared minus 4x plus square root of 3 is equal to 0. All right, how do we solve this? We're going to use quadratic formula to solve that one day. Yes, quadratic formula. So 4 plus minus 4 squared, which is b squared, minus 4 times by a times by c over 2a. So that becomes 4 plus minus square root of 16 minus 4 times 3 root 3 times by root 3 is equal to 12. Oh, pretty good. And luckily we'll get a nice number, so 4 plus minus square root of 4, which is 2. That's just 2 over 2 square root of 3. Alright, so you've got two answers. The first answer is x1 equals to 6 over 2 square root of 3, and x2 is 2 over 2 square root of 3. Nice number. Alright, nice number. Now becomes 3 over square root of 3, which is 3 root 3 over 3, and that's equal to root 3. A nice number again. I'm so excited to see those nice numbers. Alright, as you can see, the question is designed where the question asks you to get those numbers, so it's much easier for us to solve an equation. Alright, so once we get to that point, then we can just rewrite this. Cotangent alpha is equal to root 3, and cotangent alpha is equal to 1 over root 3. Now we just need to solve these two. Again, cotangent alpha is hard to solve, so how about we change it into tangent alpha? And it's just reciprocal of that number there. And we can change that cotangent alpha to tangent alpha, and that becomes reciprocal again. So that means we just get to the same point, all right? Now we can just start to solve this. Alpha is equal to, for the first one, 1 over square root of 3 is 30 degrees, and 30 degrees is pi on 6. And then the next one is all station to central is pi plus the angle you get. So you get pi on 6, and you get 7 pi on 6. Here on this side, it will be pi on 3, 60 degrees, and then pi plus pi on 3, you get pi on 3 and 4 pi on 3. Okay? Alright, so finally, the answer will be pi on 6, pi on 3, 7 pi on 6, and then 4 pi on 3 in ascending order. And that is the answer for the question. Alright. Okay, alright. So these are the 3 examples to show you the level of difficulties of the questions. They can be very tricky, those questions there. But remember, you do need to use the formula there for you to solve tricky equations. I guess some of the questions are just revision for you guys, so you should be able to do those ones. Okay. Thanks for watching. I hope you enjoyed the lesson. Thank you.